Question 3, Part C. The diagram shows 2 points A, 2, 2, and B, 1, 5 on the number plane. Copy the diagram into your writing booklet. Part 1. Find the coordinates of M, the midpoint of AB. The coordinates of the midpoint of interval AB is the average of the x and y coordinates. Referring to the diagram, there's interval AB. There's point M, which represents the midpoint of interval AB. And to find the coordinates of point M, we average the x coordinates of points A and B, then the y coordinates of points A and B. And recall, to find the average of two values, we add those two values together and then divide by the number of values. In this case, divide by 2. So the average of 2 and 1 is 3 over 2, and the average of 2 and 5 is 7 over 2. So for completeness, showing the working out, the coordinates of point M, 1 plus 2 over 2, 5 plus 2 over 2. Therefore, the coordinates of point M is 3 over 2, 7 over 2. And it's shown on the diagram here. Part 2. Show that the equation of the perpendicular bisector of AB is x minus 3y plus 9 equals 0. The perpendicular bisector of an interval is a line that passes through the midpoint of that interval at right angles. In this case, the question is asking for the equation of the perpendicular bisector that passes through interval AB. So the perpendicular bisector will be 90 degrees to interval AB, at the same time passing through point M, which is the midpoint of AB, which has coordinates 3 over 2, 7 over 2. So the first step is to find the gradient of interval AB. And we can use the 2-point gradient formula, y2 minus y1 over x2 minus x1. So the gradient of AB is equal to y2 minus y1 over x2 minus x1. Substituting the values for these coordinates, we get 2 minus 5 over 2 minus 1, which equals negative 3. Now the gradient of the perpendicular bisector is given by negative 1 over negative 3, which equals 1 over 3. Now the perpendicular bisector cuts AB in half, hence it passes through the midpoint M, which has coordinates 3 over 2, 7 over 2. So we can use the point gradient formula with the gradient that we just found and a point that the line passes through to find the equation of the perpendicular bisector. So using the point gradient formula, we get y minus y1 equals m outside of x minus x1. So y minus 7 over 2 is equal to 1 over 3 outside of x minus 3 over 2. Now multiplying everything by 6, which eliminates the fractional components here and here, we get 6y minus 21 is equal to 2 outside of x minus 3 over 2. Expanding the brackets on the right hand side here, we get 6y minus 21 is equal to 2x minus 3. Putting all terms to one side and combining the like terms here and here, we get 2x minus 6y plus 18 is equal to 0. Notice that all terms here have even coefficients and the constant here is even as well, so we can divide everything by 2. Therefore, the equation of the perpendicular bisector is x minus 3y plus 9 equals 0 as required. Part 3. Find the coordinates of the point C that lies on the y-axis and is equidistant from A and B. Any point on the perpendicular bisector of AB is equidistant from points A and B. In other words, the distance from that point to A and B is equal, thus forming an isosceles triangle. Now it's given that point C lies on the y-axis, which means the x-coordinate of point C is 0. So substituting 0 for x in the equation for the perpendicular bisector that we found in part 2, x minus 3y plus 9 equals 0, we get negative 3y plus 9 equals 0. Moving the positive 9 over to the other side to make it negative 9, the equation becomes negative 3y is equal to negative 9. Dividing both sides by negative 3, we get y equals 3. Therefore, the coordinates of point C is 0, 3. Part 4. The point D lies on the intersection of the line y equals 5 and the perpendicular bisector x minus 3y plus 9 equals 0. Find the coordinates of D and mark the position of D on your diagram in your writing booklet. On the diagram, I've drawn the horizontal line that corresponds to the equation y equals 5. So it's a line that's parallel to the x-axis passing through the y-intercept of 5. Also note that it passes through point B, which has coordinates 1, 5, since they are equal height from the x-axis. And the line y equals 5 will intersect with the perpendicular bisector here, and it's marked with the point D. Point D lies on the perpendicular bisector and has a y-coordinate of 5 since it intersects with the horizontal line y equals 5 as shown in the diagram. So we want to find x when y equals 5, which corresponds to the x-coordinate of point D. And we do that using the perpendicular bisector equation that we found in part 2. So substituting y equals 5 into the perpendicular bisector equation, we get x minus 3 times 5 plus 9 equals 0. And 3 times 5 is equal to 15. So x minus 15 plus 9 equals 0. And negative 15 plus 9 is negative 6. So x minus 6 equals 0. And solving this equation, we get x is equal to 6. Therefore, the coordinates of point D is 6, 5. Part 5. Find the area of triangle ABD. One way to find the area of triangle ABD is to recognize that interval BD is a horizontal interval. In other words, it's parallel to the x-axis. Now, we found the coordinates of point D in part 4, and the coordinates was 6, 5. So to find the length of BD, it's just the difference of the x-coordinates of point D and point B. So 6 minus 1 equals 5, and that represents the base of triangle ABD. To find the perpendicular height of triangle ABD, it's just the difference in height between point A and point B. And we do that by finding the difference between the y-coordinates of point B and point A. And 5 minus 2 equals 3. And that would be the perpendicular height of triangle ABD. So to show the working out, I'll just go through it quickly. Let BD represent the base of triangle ABD. Hence, BD is equal to 6 minus 1, which equals 5 units, since BD is horizontal. The height h of triangle ABD is the vertical distance of point A from interval BD, given by 5 minus 2, which equals 3. And the area of a triangle is given by the formula half times the base times the height. And in this case, the base is 5 and the height is 3. So area is equal to half times 5 times 3, which equals 7.5 square units.